Thank you all for joining in today. I think day one, after the day one session, wherein we uh, had typically broad-based the entire thought in terms of how and what kind of modeling activities we are doing at SUD Life and how is it helping our businesses to also latch on to some of the models that we have developed and possibly create some advantage and some business benefits for the organization. We also talked about something which was more related to how those models were also looked at from an adoption perspective. How do we actually discuss with our business stakeholders? How do we go step by explaining what we have in the model versus the descriptive statistics being first, then trying to identify variables in terms of looking at different ways of business processes, understanding this from the business teams, and trying to apply all of these into the modeling activities. We also try to cover a couple of new age tech that we are also using at our end to possibly enhance our models and model accuracies to a higher extent. Um, what we essentially would be covering today is more in terms of a hands-on session, which is obviously in some time that we will be starting with, but a context setting and an agenda that has to be brought in for today, which specifically deals with what are we doing as a deep dive in terms of the process that we follow for statistical model development, not only for renewal models, but the same process is also followed for other propensity models that we create at our end. While the techniques of the statistical modeling techniques will be different for every single model, because that is how we also try to gauge which technique, for example, whether it is an XGBoost or a logistic regression or an SPM or a random forest, whatever technique that we use at our end, we try to do a comparative analysis of these techniques, be it classification regression. These techniques are then applied and tested on all the data set that we create at our end, and possibly ways in which these data sets will also be analyzed not only at a statistical modeling perspective, but also giving those outputs to business. Because ultimately, the goal of every statistical model and what we also have seen is the adoption typically depends on how easily will the business be able to understand an actionable insight from that model. While the model will always be giving a score in terms of how a policy score is there, how a customer is being scored, what are the ways in which product scoring helps in terms of having a direct weightage for the model development. But also, what will happen is with these scoring, business understands what we are trying to explain, and vice versa. So is also important. So, I think as a part of this, we will also uh, try to explain uh, bigger blocks of variables, which means if we are talking about customer as one single pillar, what would be the details of customer that we ideally in a life insurance organization would be having, and what are the ways in which we capture more and more data? Because ultimately, if there is more quality and quantity of data, that helps in making the statistical model more robust to that extent. Post which we will go into a part which is more of mapping whether these variables are statistically significant for us or not. And through the statistical techniques, we will try to also go towards looking at how do we also plot ways in which the model is stable or not, and the stability index of the model will also be talked about. So, um,
Uh, yeah. So yesterday we were discussing like we have to identify all the data points that are there in the system which have been captured. So here what we are trying to showcase is a detailed list of the fields that we at SUD Live have identified and then try to use it. So I will just open this Excel sheet and try to maybe showcase what are the fields that we have.
So what we are trying to present here, it is more about exhaustive list that we think always should have been there. Out of this exhaustive list, we will also go upon what is the field listing that we have used in the SUD life balance, because obviously these data points are something some regions might have it very handy, some regions might have to cull it out through certain processes. Some parts we also would not have in SUD life, because what will happen is possibly there will be some systems which will be storing data. There will be some systems which have undergone rapid changes due to transformation. Hence, we might not have chunks of data for last 10 years or so. Some systems also evolve as we move ahead. For example, policy admin system will be the oldest, but maybe a calling system would have come after 2 years. Reason why? Because number of callings would have increased, the way in which call center accuracy has also increased. So system data versus the data which is available in every model will always be changing, and we have to also take into consideration what kind of data, where is it statistically significant or not. All of those factors have to be taken into consideration before we actually jump on to the model development activity.
Yeah. Here what we can see is different points getting captured under different categories, which will again be used at a later stage when we are trying to explain the importance of those variables to the business teams. So when we are deploying or trying to use this at the end consumption stage, the user has to be in a state wherein which the insights that the model is saying are to be understood in the right way, and then can create a strategy on which they can act upon. So, for example, here customer profile, customer lifestyle, and agent details, sales details, and branch details are there. So, what we can do is, for example, for a particular policy, the score that is contributed from the proposer or payment details is on the higher side. So, we can look for a strategy or an option wherein which if the payment is a problem for the customer to make it happen, then we can look at some messages in which maybe a link for the payment is been shared with them, so that the ease of transaction is made easier for them, so that the payments get um, collected within those due or within the tag that are there within policy systems. Similarly, what is the customer interaction history that is there? Any grievances that they are there from their end? What is the sentiment that is being calculated at the touch points that are there? For example, if there is a call that is happening, are we trying to understand the sentiment of the customer? If there is a frequency associated to a communication channel that was there, so we can assign it to a preferred mode of communication to that particular customer, and then maybe adopt our strategies through those communication channels. So, for example, in our case, what we see is in tier 2 and tier 3 regions, people prefer a branch visit rather than coming to an online platform. In tier 1 cities, it is more like people come onto our portal and then try to have those premiums paid. So for tier 1, it would be a different strategy of communicating to the customer, saying that for tier 1, we would be sending one URL where which they can click on and try to have those premiums paid. For tier 2 and tier 3, it would be more like a call that is going to the customer saying that your renewal is due. Please visit the nearest branch, and you can pay via check and other modes that are available to you. So when you analyze the customer interaction history, you try to identify which are the points or which are the touch points in which majority of these communications are happening, and try to focus on those areas in which your strategy is also being applied. So what we can do is maybe compare. Yeah.
One thought when we usually try to do or analyze customers across different regions within the country. I think there has to be a lot of thought which obviously emanates from the point of people knowing their customers better. So what Jagdish was also trying to explain, how we do it in India, it is more like a tier 1, which is metro cities, then tier 2, which is suburban cities, but not the metros, and tier 3 and tier 4 are more on the rural side of business. that we have. Now, with the promoters that we have, which is Bank of India and Union Bank of India, which are two public sector banks in our ecosystem, our branch network of these branches is spread across the entire India geography, and it has more than 14,000 odd branches. Now, when we try to look at this, the penetration of customers, if we see it, it is also skewed. It is not evenly distributed across regions. There will be very different ways in which this data is also being analyzed, because geospatial analytics is one part which we also do at the time when we are trying to assign branches which are bank branches to our SUD office branches. So how that funnel usually happens is 14,000 odd branches are actually being consolidated over to 140 or 150 odd branches, which are the epicenters or focal points for us, wherein our agents or our representatives, SUD representatives, will be stationed. And these are the focal points to which different branches within the country, or we also try to do that segmentation and analyze whether these branches are equidistant or if the distance between these two branches, for example, SUD office is the focal point, and there are five or six branches which are in the distance of, for example, 25 kilometers. Will the agent be able to handle the customers related to these 25 kilometers? If there is something beyond 25 kilometers, possibly the outreach of agent might not happen. Hence, a different set has to be given to these customers, and these customers have to be handled in a separate way. These, all of these thought has also gone into the model, because ultimately, when the sales is being done, the sales target is exactly correlated with this point, the distance, and the mapping of bank branches to the focal point of SUD branch. How this gets correlated is uh, when the target has to be achieved by these people. What we usually see is suppose uh, uh, one SO, which is our sales officer, which is the uh, most granular level of hierarchy, who is selling the policy to the customer. His target is being understood. His target is basis um, five bank branches assigned to him, which means whether he can visit these five bank branches within a radius of 25 kilometers and sell policies to that. Even this is identified in a statistical model, which helps us to know a geospatial tagging, so that what is the golden number of branches which the SO can handle without uh, um, possibly exceeding or overburning himself. Because what will happen if the branch is not active, the policies also will not be sold. Whether his expense is limited to only three branches or five branches, that is a modeling activity that we also do at our end, which is the baseline for identifying your sales figures and the way in which SO also deals with your customer. So this kind of data understanding goes in the backend to actually reach on to this sales. So we would also maybe try to understand from your end if there are certain processes like this in terms of knowing how does the SO or the sales officer go and discuss with the customer. What is the challenge for him to actually do it? If there is a challenge, we also try to map those data points at least as a indicator. While we will not be able to cover all of this in today's session, we will just try to understand it first, work on the variables that we have at this point in time, and then see how we can take it. Okay.
So what we can also do is maybe use this particular field list and compare maybe what are the fields that are available here as a whole, and then maybe try to fit in into different categories like we have segmented at our end, and see if we can maybe have those fields also extracted, or try to have that maybe at a later stage from the business point of view, saying that if you can please provide those or try to have these fields populated when the data entry is getting happened.
So as we go into the details, what Jagdish is explaining is if we can have two columns mapped against these fields, saying which are the fields which are available right now, which are the fields which are available in the system as a whole, and which are non-available at all. So we know the focus areas and what is our entire expanse that we can do during our session.
Yeah. So other parts we have covered it yesterday, like how to create those data quality reports and then publish it to the business, saying that what is the percentage availability, what is the quality of those data points that are available. Yesterday we have covered them. So then going to the next slide, where we will be covering detailed aspects of stability indicators that we would be wishing to compute today, and see with respect to DLB and what is the stability of the model that is there. As a part of our model evaluation activities, what we try to do is compute one more parameter, which is K-stat, which would help us identify how good the model is in distinguishing between a bad event and a good event. So it tells us, or it helps us in identifying those lapse cases, and probably maybe a disciplined or people or customers who will pay within the time in a better way, is what we can derive out of this matrix. Ideally, K-stat would be presenting, or would be should be in the third decile with a value of more than 45 is what we have as a benchmark. And then the same value has to be then followed in the out of 10 testing, and in the pilots that we do, the same value should be there, at least close around in what we have observed in the train set. So K-stat is one important parameter that we have to compute, and then along with that, we would be using one more stability indicator, which is population stability index, which tells how relevant the model is to the data that is there. So as we were discussing earlier, there would be certain trends in the products that we sell. Maybe due to certain scenarios, a certain kind of product, maybe unit link, the focus is not there much. Earlier it was there, but then the focus was shifted towards more on traditional product. So there is a shift in the trend. With shift in these product trends, there can be some shift in the data trends of the customers that we are onboarding as well. So population stability indicator would help us understand if there is any data change that we are seeing over the period of time on which the model has to be used. So this is one indicator that we would be again computing in due course of time. So I should check if there are any stability indicators are within the limit or not. Ideally, PSI should be less than 0.2. If it is close to 0.2 or slightly greater than 0.2, what we feel is there is some instability that is creeping in. Maybe it is not that critical at that moment of time to maybe rectify that. If it is greater than 0.3, then definitely we should look back at our model, saying that there has to be some rework that has to be done. If it is between 0.2 and 0.3, then we should maybe have it as a concern, saying that there is certain data change that is being observed. So we should maybe check for which column which is impacting. And for that also, there is one more metric, which is CSI, which particularly tells about the individual variables that are contributing to these changes. So it can so happen that in certain period of time, the customers that are onboarding maybe belong to certain age group, 25 to 30. But as the company is progressing, it might so happen that the customer age now is not 25 to 30, it is somewhere between 35 to 40. So this is a change in the profile of the customers at the individual parameter level. So we have to identify these changes as well, and then it would help us to maybe tune the model to that extent, saying that now maybe the customers that are getting onboarded um, uh, are the subset of a different profile altogether. So we need to have those alignments or changes in our model as well to have that accommodated.
And usually, once when the models are developed, for example, we develop the model in the first quarter of the year. Just giving an example. Uh, what we usually try to do is, as Nagin is explaining, PSI and CSI are some indicators for doing this. We would also, by end of a quarter, try and see if the model is stable, and also run the same techniques that we have used earlier to possibly see if the model is consistent enough to predict for next quarter or not. So, model evaluation and evaluating it time and again helps to keep the model accuracy uh, in line, and at the same time letting the business users also know that there is a training, testing, validation about on the model that is happening, so that business users are also confident in saying this models are being checked thoroughly. Because what will happen, it is the same thought when we try to do whenever a system or a new application has to be brought into place, there will be a development environment, there will be an SIT, system integration testing that people will be doing. Then it will be a UAT testing, which means the user acceptance test for the systems that are being given to users, and they will also do data entry. They will also see if the system is being created as per the BRD or not, and then ultimately it moves into production. Once it moves into production, obviously people keep on using this system uh, day in and day out. Hence, they know if there is any bug in that system, that bug is being highlighted to, example, the IT team or the development team, and they rectify it. Similar SDLC, which is your software development life cycle, in a model parlance is what we also try to follow, so that whenever the model outputs are being shared with business users feel that confidence in terms of using it to the best.
So here, what I have plotted is also an explanation of how KS can be observed along with the capture rate that we are looking at. So if you see the trend across the deciles, there is a decreasing trend of capture rate that is being observed. So in the first two deciles itself, majority of the events are being captured, which ideally the model should be doing. And then if you also look at the KS range that is there in this particular graph, the KS is ranging somewhere between 30 to a minimum of close to 12. So ideally, KS should be there in third or fourth decile, which is in the range of more than 45. And the capture rates that are there across these deciles also should be in a position for saying that if the business is asking maybe high risk segment I would need, it should be within a range maybe 85 to 90%. It has to be accurate enough so as um, strategy can be applied on top of that. Um, um, if at all there is a challenge in the quality of data, if at all there is a challenge in terms of collecting the data itself, then what we generally suggest is maybe a statistical model can help if there is a large volume that has to be handled. But in that case, given the data quality or there is some issue in terms of collecting the data, the model accuracy or efficiency would not be there to that extent. So in that case, what we suggest to the business teams is, since you are having certain bandwidth issues in terms of handling these volumes, you please go ahead with this current model, which is maybe at 75 or 80% accuracy. As we go on, as we implement this model, we would be capturing those data points in a better way and try to loop back those variables back into the model and then improve from maybe 78 to 82, 83, which is an ongoing journey which would eventually be a continuous process of improvement that is there for a model life cycle. So this is generally what we push our business teams to have this models in place, so that to some extent maybe 80% model accuracy would also suffice if the given volumes are huge enough that it cannot be handled.
So the answer to one of the questions that you were asking yesterday, it was more towards what should we give to the business. The answer to that is first or second decile customers are the ones who will ideally, uh, if the case statistics is in the right order as being explained, the easiest way and the most high or the highest probability of lapsation would ideally be in your first two deciles. This is the safest bet that you can take on the model while giving those customer details to the business teams. Because what it ideally means is if we try to see a lapse probability model, it also talks about a discipline base for us, because the higher deciles will talk about customers who will definitely lapse, and the lower deciles will talk about customers who are your discipline base. So this solves a two-pronged problem for you: identifying your discipline base in the right way, and also identifying your lapse probabilities. Now, the thought has to be also discussed with the business as to which is the most disciplined base, which is the lower end of your decile, which is ninth and 10th decile, and the riskiest segment, which is your first and second decile. These are your sure shot answers to the questions. And the middle range is where you will have to take the judgmental call. Obviously, it is basis the percentage of probabilities that are spread across. Now, when the model accuracy and stability has happened over time, obviously this gap will also keep on bridging, which means first and second decile will move on to first, second, third decile. From the discipline base, it will move on to 10th, 9th, and 8th decile. So at least you have covered six different deciles within your business. 60% of the business for you is a sure shot thought, saying that this is my lapse base and this is my discipline base. Middle base is something which will always skew towards your left hand side or right hand side at any given point in time, because the probabilities always will be falling into that category.
And one more important concept that can be used to convert variables with huge cardinality is a binning technique that we generally follow in HB Life. What we use is weighted evidence and information values to help us convert those columns with heavy cardinality. For example, if we take the banker channel in India, there are 15,000 banker branches which are spread across pan India. So if we look at bank as a parameter in our variable, it would be more than 15,000 categories that are there as a data point. So we cannot use 15,000 data points and then encode them as an individual column in our data model. It becomes very confusing for the model itself to identify any trend. Also, the amount of effort in terms of computing those calculations is also complex. So, in order to avoid this, what we do is to bin them logically using weight of evidence calculations. By weight of evidence, what we do is we understand the distribution of good and bad events across those particular categories in that particular column, and try to have a weight of evidence computed. And then what we do is categories with similar weight of evidence would be binned under same segment. For example, there are 10 branches, maybe in the southern region of Vietnam, which are behaving similarly with similar WOE. So you can map all those 10 branches into one particular bucket, saying that maybe DLBN South 1, which is a segment of 10 branches within that particular geography with similar weight of evidence. Then when you use that variable as a parameter, instead of maybe having 15,000 or heavy cardinality feature, you would be having 5, 6 categories in that variable. which would be more helpful in terms of getting those accurate predictions. And also there are certain prerequisites before we do this. We have to ensure that each bin or each segment in that particular variable should have at least 5% of the data that is there in that particular segment. For example, 10 branches in southern part of Vietnam, it should at least contribute to 5% of the total data points that are there being used in the business. So we should ensure, for example, 4 to 5 bins in each column is what we ideally look at. It can go maybe 6 to 7 also, but ideally we keep it 4 to 5 bins having 5% at least in each bins of those variables. So these binning techniques we use is for all categorical variables. For example, yesterday, as we were discussing, there is an occupation column which would be having maybe a list of plethora of options which are there in the system. It would be maybe greater than 2000 or 2500. So in order to put all those occupations back into the model as is, would be difficult for the model also to grasp what exactly the trend is. And also it is a complex calculation that is involved. So we can maybe combine those occupations into maybe 5, 6 categories: occupation 1, occupation 2, occupation 3, occupation 4, and then have those binning done, and then use that variable in our model. And also, so weight of evidence is one technique where you are actually using to reduce the cardinality of those variables. There is one more technique which is information value computations, which would help in understanding whether this variable is actually important or significant in terms of predicting those good or bad events. So again, there comes a certain range for these information values as well. Ideally, it should be less than 0.5 and greater than 0.15. So somewhere between 0.15 to 0.5, these values should range between. If it is greater than 0.5, it is too good to believe. So we can say there is something fishy, or the variable is maybe biased towards a certain data point. So it is too good to believe, and we can ignore that variable. And if it is less than 0.5, 0.15, we can say that the significance or the predicting power of that variable is not that high, and we can still consult with the business. So in SUD, what we follow is at every step of these computations, we go back to the business, explaining the computations that we have done at our end. Though statistically, the understanding might not be there, but sometimes it might so happen that we are looking the data point in a different point of view, from a different point of view. And what the business is, that data point can altogether change our perspective. Example, like we were discussing yesterday, we also had this problem of binning those occupation variables. We also had some issues in terms of outliers in the annual income that is there. We also had some issues where the customer is saying he is belonging to an occupation agriculture, but the income levels that is corresponding maybe to that particular occupation are not in line with what we observe. So we go back to the business saying that this variable is not coming important or significant, but you are saying in your experience there is a high chance of probability, high chance of lapsation for this customer. So what could be the possible reason for this? So then they will say, maybe in my experience, this is what you should look at. And then we try to map those with the data at the back end as the main driver in order to understand those logic significantly. Then we again map those occupations or renewal dates with the time at which these renewal payments are done, and then we arrived at that maybe harvest months are those where farmers are like available with sufficient funds and they make their payments on time. So that is how we do a to and fro continuously with the business teams, trying to understand their point of view. At the end, it is the ground sales team who are highly interacting with the customers day in and day out. The banker person who is there trying to understand the customer who is maybe coming in by a walk-in. anyways, a walk-in cannot be captured to that extent, saying that these are the data points that the customer was walking in and he was discussing these points. Those data points are not there in the system. So we have to discuss this out with the banker person, the sales team. What are the problems? What are the challenges? Maybe in terms of them paying the premium. Then we should maybe convert that problem and try to map it with one or the other data points that is available as a surrogate or a direct information.
So one discussion point that also comes up when we were also trying to understand why is this cardinality so high. First way in which we should be addressing it, as we were discussing, is try and go to the business and say we want to reduce this cardinality to some extent. Occupation was one good example. You will have the possibility of different regions because the spread of regions will be also too high. And if within that region there are multiple cities also available, and within that city there are multiple areas also available, that also increases the cardinality. So we should go back to the business or use some descriptive analytics to say if we can try to reduce that cardinality to some extent, because uh, before performing WOE, weight of evidence test, one round of discussion with business should be done so that one mapping is ready for you from a business perspective. And the weight of evidence also gets attached to it, and you are there sitting with comparing two inputs. One is your business input, and second is the statistical model data input that you are having from the WOE. And you can have those quality discussions with your business teams saying weight of evidence of data that is captured in the system is showing some different flavor to it. Whereas what you were saying, the business team has a different connotation to it. So wherever these mismatches happen, those will be very quality discussions that the actuaries team would be having with the business team to understand if the data has to be enriched further, or is there any gap in terms of our understanding versus what the business is trying to give. Now there will be it is more of you going and challenging the business as to whether the thoughts that the business team is having at their end is in the right spirit or not, because now it is backed with a data evidence for you. And if the business is contesting that a specific region performs better always, but you have some data saying that this region performs because of only one or two specific agents, then this information also has to go back to the business saying that there are only two agents who are performing in this entire region because of which your region is looking good. Otherwise, if you remove this, there is a lack in terms of understanding if the business can be extended further or not. So such discussions will come out when these steps are being performed and those calculations are shared with business so that some quality inputs also can come out.
And at this point, maybe I would like to also share a few challenges that we have faced while we were building the model. So at one point, as we have showcased you, the list of variables that are being considered. So there are certain variables that are related to agents. There are certain variables which are like the sales field in SB, right? And there are certain variables which are related to the branch level details. So when we are trying to identify these trends, what we observed is maybe a sales trend or sales related parameters are becoming significant in terms of predicting the good or bad event. But the problem with this variable is the sales attrition is also a challenge. So you don't have people in the system for more than maybe 4 years, 5 years. Sales maybe it could be even less. People come, they work for 2, 3 years, and they move on to another industry or another company. So using a sales related variable in a model becomes little tricky because there is a continuous attrition that is going at the back end, and you have to again plug in the new SO that is coming in, which is the sales officer. And when the sales officer is new, he doesn't obviously have any records to his track record. So it would be an empty value that we have to use there. So in order to mitigate this, what we have done is maybe instead of using a sales related variable, we would be using a branch related variable. The branch is there. What we usually observe is there is a certain trend in this is specific to our region. If a bank is doing good in terms of the new business that is there, the trend generally tends to extend to the other time frames as well. And if a bank is not doing properly on the activation or the new business is not good, then there would be certain spikes in the data saying that maybe with the change in some sales officer, there would be certain spike, and then maybe after that attrition has happened, it will again drop down to the initial values. So there is this trend that has been observed, and then in order to nullify the attrition problem that we had at our end, we used the branch parameters that is there instead of a sales agent variable directly. So this is how we could also maybe tackle the attrition challenge that we had at our end. And parallelly, as I was talking about attrition, we have a specific algorithm which talks about the attrition percentage of the sales employees as well. So we try to have this shared with the operations and sales team so that they can also save some budgets on the training the development activities that they also do for the onboarding and training of all the sales officers that are there. So we have this model running on ad hoc basis whenever the business feels there is this problem of attrition on the higher side. We generally try to identify those high risk sales officers, have those conversations in place with the regional HR officers, coordinating with them, trying to understand what the problems are for at their level and try to address them so that that attrition is probably arrested. So these are some proactive measures that we also take at our company in order to arrest attrition, which would eventually help in maintaining that stability and getting the constant new business that is there.
So similar things does it happen here in Vietnam, wherein attrition at sales level will be high and people will be switching jobs.
Yeah, a combination of agent, right?
Yeah.
Maybe more than 50% or 50% in the first 2 years.
Okay. Okay. So, but does this mean that obviously a loss of business also happens with respect to suppose this agent has gone anywhere, and then he will also have his customers also taken out of this and invest into a different life insurance company also.
Yeah, that might be, but it depends on the case. But some of the case will go when the agent terminates. Some we can keep. Yeah, it depends on the case. But to say that most of the case will go.
Most of the cases are
Yeah,
gone.
yeah.
So I think this specific issue at our end does not crop up to that extent because it is more like a banca governed business, which means if it is a UBI or a BOI customer, only then this will he be able to get a HOD policy. The digital or agent or agency distribution channel is having a low, it does not have that much percentage into a total business. It is majorly a bank-driven organization. So the movement of customers out of our ecosystem usually does not happen. So which means you are right in saying that if the agency channel, if the agents are moving out, they will also take the business out with them. That is like a constant churn that will keep on happening. And obviously, when the new agent is coming in, he will also bring in new customers.
Yeah.
And that if within the agency channel will also reduce the persistency.
Yeah. We know that because we also measure the persistency of the new agent, existing agent, the build up between the persistency of the existing agent and with the new agent. Would that be around 20%, 20 or 30 points, something like that?
20% is the
Yeah, like 50, like 40 and 70, 40% and 70%, and 40 and 65 for both two blocks.
Okay, the new percentage that comes in is 40%.
Yeah,
And the loss that happens is 60%.
Yeah, they 65.
Okay.
So I have a question about this one. Do you disclose this information value prior to choosing the variables or after choosing it?
Uh, we will do this step computation prior to the iteration that we do.
The iteration? Okay. So does it give the same result as the variable importance package? For some
So
models?
there would be a difference in terms of the ranking that this algorithm gives. What generally happens is the beta coefficients of maybe logistic regression or the Gini indexes or the output of maybe random forest would be on a different line, and this though again this would be a log of the odds of Buoi by similar computations, but it would be then slightly different to what the other coefficients or what the other values are there.
So
So you can say maybe weight of evidence would be similar to a beta coefficient of LR model, and we can use them on the same line. But maybe compared to the output of random forest or some other model.
so for tree-based model, like the result of this equation value will be different.
Yes, it would be different.
Yes. With this one is easier to communicate with stakeholders,
This
right?
one would be easier to communicate with the stakeholders,
Yeah.
and also with the weight of evidence values plotted. There is one more technique that you can do, which we were discussing yesterday. You can compute the scorecard of the customer. So you can convert these values onto a scale of maybe 800, 660. Generally, I think in credit scores it would be like on that only. So you can compare like on a scale of 800, what is the parameter which is contributing to the most. And just showcase that.
And whenever any kind of a technique is being used, obviously the backend algorithm will be tad bit different. Be it from an LR perspective, be it XGBoost, be it SVM, there will be different ways in which probably same part of weight of evidence or information value is communicated through a different technique altogether. It also changes with different softwares. So Python is a software which will give you maybe some amount of additional advantage to use different libraries. R will give you some more advantage versus disadvantage. And if you put in the same variables or the same data into a Python or an R model, the backend libraries also will have some of the other typical way of computation, which means even though example a logistic regression or an XGBoost is being used in R or Python, the output percentages will obviously differ. Why? Because the computational libraries in the backend are also very differently coded. Same will also happen with some enterprise solutions like SaaS, because earlier SaaS was very heavily used in terms of either it is E minor capabilities or enterprise guides that they have at their end to run statistical modeling, because the banks usually are the bigger stakeholders wherein SaaS is used. The output of SaaS will be also tad bit different from these results. So it is obviously while we do all of these encodings and way in which the probabilities are also being mentioned out, there will always be a judgmental call that has to be taken by the business saying probability if we are saying it is 94%. It is in that 5% of confidence that we also have to play around. So that is how when we are explaining it to the business, we will have to give a confidence to them that even if this model is being created in a different software, the results will be a tad bit different. So the confidence that you have to build is more in terms of a stable model to be given as an output to people.
I mean, the point thing, I understand that. Like even like if you use the same model, if you have a different seed, different setting.
See,
Yeah,
yes,
and
you're
for
right.
sure,
Yes.
like the results will be different. But at the same time, what I'm afraid of is like if you present, for example, like the WOE or
ID
the information value. I'm not sure whether like if that information is or like that calculation is applicable to a certain degree of model that we use, because like you have mentioned that you guys like for the final model you guys use logistic regression. So I think like this information is very like really, it aligns with the LR. However, like, because I'm not sure if this the same thing can come for like tree-based model. So that's what I'm afraid of if you talk to like some sort of like other data scientists.
Yeah. So what we do at our end is also maybe the approach is not that we will be going ahead with logistic regression in the first place. As we also know that there are a plethora of options available, we will be comparing those logistic regression, random forest fit, XGBoost, or some other model like SVM. We would try to compute the results of all these models and then see what is the difference between these models in terms of all the parameters that we have listed earlier. Be it accuracy, be it precision, be it F1 score, those are they calculated for all those iterations that we do. And also we see how stable the model is in terms of all these algorithms in the long run as well. For example, we are extending the same results of the train set to OOT and then out of time testing, and then in the pilot phase as well. Then we compare the results that are there. So generally, what we observe is in terms of random forest or a tree-based model, the amount of fitting that these models try to have on the train set itself is a little on the higher side. These models always try to fit as close as to the trend that is there observed in the train set itself. So when we extend the same models to other data time frame, there is a high chance that there is a deviation observed in the long run. And in the case of logistic regression, what happens is with these techniques in place in terms of maybe IB, WOE, we also eliminate the possibility of having outliers uh, through these techniques because we are already binning those variables to that extent. And then the possibility of outliers impacting the data in the long run also becomes negligible in terms of using an logistic regression. Though the accuracy would take a hit maybe on 1-2% level. What we have observed is if logistic regression is giving 85% on our train set, then at max an XGBoost would all with all those parameter tuning would yield the 87% result. So that 2% result over maybe 6 months or 1 year, when we compare it with logistic regression, then logistic regression becomes a stable solution if we compare with the changing data trends and changing population that is there at least in Indian regions. So that is how we compute, test, and then with all those observations in the pilot, we then decide the algorithm. And at some point, if we find logistic regression is not giving the result that is expected, then we these monitoring things that we do is on a monthly level that we sit and discuss with the business teams. So in a month, maybe logistic regression the results are good, and in a month maybe XGBoost is giving a good result. So we compare those results in the coming months as well. So month one logistic regression versus XGBoost, month two logistic regression versus XGBoost. So in maybe a trench of 2-3 months, if logistic regression is not performing as expected, then we switch on XGBoost in terms of the final score that has to be used rather than logistic regression. So that is how we follow in our practice. So it is not that logistic regression is final, then it will go on with the time frame. That is not the case.
What newer techniques and ML ops, what it talks about nowadays when it comes to AWS, SageMakers, or Azure, Azure services for ML ops, Azure ML. What we usually do within Python from a coding perspective, which means that we will have data pre-processing steps, steps of running data, then plotting a confusion matrix, and then trying to see what is the stability of this. A lot of these are automated to a maximum extent now with the the likes of AWS and Azure, wherein the comparison of what this is trying to explain is actually an output of 4 or 5 models directly being given with the comparison of confusion matrix, saying that what is the accuracy, what is the recall, what is ratios of PP versus NP. All of those are also computed directly. How life has become easier, obviously, for a lot of people is once these data points, and why WO and IB is important, it is more towards saying that the variables that we have selected have some thought being put into it. Otherwise, all models, you can just write a GLM, give a data, and write everything, and you will get a. It is more like an Excel, garbage in and garbage out. But whether that work that is being done as a one single coding snippet versus what you have put in as a bigger thought into the entire model creation is a long-lasting aspect for the organization. Otherwise, so we know people would definitely be wanting to rush for identifying whether a given model is better or not. What we are also trying to say, different models should definitely be compared, and the best fit is what has to be taken ahead. In our cases, when we do those comparisons between 2 or 3 models, we have found out sometimes LR has worked. We have found out there have been, because some other problem statements within the classification models of random forests have also worked for us. As we were talking about the geospatial analytics, there obviously classification techniques will only be working and not the regression techniques. So there will be a different model which will be different modeling technique that will go into that solution. The point that we are also trying to harp upon is the way in which data pre-processing becomes very important aspect of before going into the model development.
Maybe
I think if there are any more questions, you will also want to answer.
So no questions. I just understand overview that this scoring is the way to measure. Why do we have this scoring?
as I was trying to explain yesterday, these models, maybe the way we appreciate these algorithms, the point of view, maybe from the business angle, may not be in a position to appreciate what the model is exactly trying to say. Maybe it could be a black box for them, saying that okay, there are some variables going into the black box and there is some output coming out of that black box.
Yeah.
So it becomes a black box for the business users to understand to such extent. So what we try to do is, in order to have their confidence of what exactly is also happening in the model, we try to convert these probabilities onto a scale. Maybe a probability of 0.94 risk of a customer lapsing won't make such sense to an end consumer, who is the business user at the end, who has to make those calls to the customer trying to have those lapsations arrested. So for them to understand, what we try to do is maybe use all the input variables that are there, scale those probabilities that these variables are contributing to the final output probability. For example, x1, x2, x3 are the variables that are used in the model. If we are using maybe a logistic regression, the beta coefficient, which is beta 1, beta 2, beta 3 for these models, would then be scaled to a value. Maybe 0.2 weight beta coefficient would be then a score of maybe 200 in our scorecard mechanism. So this combined 200 value from maybe the financial stability indicator of the customer, another 100 score that is coming from another input variable x2, the beta coefficient is then converted to some other score, which is maybe 100 contributing to the final output. So combined x1, x2, x3, all the variables, the combined output is close to 700. So out of 800, your customer has scored 700 basis all these input variables, and maybe financial stability is the reason or the cause due to which the customer is lapsing. So that point gets highlighted, and he also understands, okay, this is the reason why the model is predicting this customer as a bad customer or a good customer. So that confidence of the business user understanding the model becomes easier to that extent, and they also will know that maybe out of 15, 20 variables, these are the variables that are to be looked at, and maybe where the scores are on the lower side, maybe these are the reasons why the scores are low, and maybe we have to focus on those touch points or on those parameters when we call or discuss with the customer. So there the utilization or understanding of the model becomes easier, and this was used by us because we also had those initial discussions with the business team. They are also not in a position to appreciate what the analytics is saying. So we have to make it simpler for them to understand and consume.
So these are more of the explainability indexes for
So, so the approach is that you have a final score, right? Final score, and after that you attribute again to
Yeah.
or category or something like that,
Yes.
right? So, or financial stability and some other like, and we use that to plan for the user. Uh, so my question is that my question is that how do we identify that category? Like, is it from input variable, or we just create that
no, these are
Input variables.
These are input
input variable.
Yes.
So we pick some input and we create some category. Is that correct?
So what we are trying to explain here is once the input variables are selected, this is some part that has been put in. We show the explainability of that input variable to ourselves as well and to the business team also. For our explainability, we are trying to give those weight of evidence and ID as measures to which we are doing it. Converting those into a score will help business also understand what is the weightage of every variable which will be contributing to the model output. We have not yet started with our modeling technique as of now. It is just a starting process wherein we are saying that the variables which are a part of this entire observation set has this much value for explaining the output. That is what we are saying.
So only
Model-
only for category.
No, so earlier the Excel sheet I was showcasing, in that there would be close to 6-7 categories. 6-7 categories, wherein which one category you would talk about customer lifestyle, one category would talk about customer profile, one would talk about the brand details, one would talk about the agent details, and one would talk about the product details, and one obviously about the geography or the region to where the customer belongs to. So there are 6 to 7 variables that categories that are there, under which we have a specific list of input variables. So all these input variables combined would then form 7 categories. These 7 categories would then lead to the final score. So the contribution of each category would be then made visible to the end user, saying that these are the contributions that these variables are having to the final score.
And within these categories, number of variables are to the tune of 60 variables.
I know.
Now, with 60 variables, if we go back to the business and talk about each variable, it will also take a lot of time. While this activity should definitely be done by saying that these are the variables and these have a higher contribution. But for an easy explanation, because now we are trying to boost the adoption of that model. For boosting the adoption or letting business know that this model has a lot of value, we would also want to go back to the business and say the customer category has 80% or suppose whatever score that we decide on 1 to 100. If the range for score is 1 to 100, we say that 80 score is being attributed to customer category, which means it will have a lot of customer variables in it. 90% score is attributed to product category. It will have product details, PT, which is policy term, premium paying term, follow that. So such way we go back to the business and say these are the variables that we have identified. Now there can be multiple iterations also in this, which means that iteration means that we go back to the business and say this is what we have identified. Business team will come back and say, I think there are four more variables within this customer category. So we will ask them, what are these variables that you think of? He will say, possibly I know that this customer also has, supposedly he will say, this customer also has a lot of general insurance which he has already taken. Now we will go back to them and say, while we are working on our data, we might not know if this person has, say, four general insurance policies with him or not. Hence, this data is not available with us, and we will not be able to do it. If the business says they have some third-party data which can be helpful, or possibly be plugged into this scenario, we will also try to appreciate that and take that data in. If they say, for example, we have seen within the loyalty program, the customers whom I am pushing to come onto that loyalty app are the ones who are staying along with me. So we will try to bring in data from that loyalty app, map it, and then try to again do these techniques, weight of evidence, information value, to make them also understand if the hunch, because this is a thought that they have in mind, which means this is a hypothesis that is put out by the business to us. Business saying that the customer who is coming onto the loyalty app is a sticky customer for me or will always renew for me. This is a hypothesis. Now we have to either disprove it or say that null hypothesis is true or false. And then we go ahead with this because these will be the ways in which data is talking uh, whether the null hypothesis is correct or false. So hence we usually do these techniques so that the confidence when we are also developing the model is always there, and confidence is also given back to the business.
So just one, so just for better illustration, could you please show some of the variables that relate to the business, the financial stability score, if you have some in mind?
Yeah. So what we have for financial stability are the annual income levels of the customer, the occupation mapping that I was talking about. For example, if the customer is salaried and then he has opted for a direct debit or e-NASH that we were discussing earlier, and then the payment option chosen by the customer is also through a direct debit option. And when we have those percentiles mapped against whether if the annual income is falling maybe close to 75th percentile within that segment, then the customer would be having a higher financial stability score compared to the others. So that is how we use these parameters at our end. And what we also try to do is, for example, we share, like this was during the initial phases of discussion with our business teams. So what we do is, along with the tag, maybe which says high, medium, low, or ultra high risk, high, medium, low, and low risk, and with the probability that is assigned with each of the policies, we also try to have all those variables that are there being used in the model, score them on this scale, and plot a contribution against each of those variables. For example, there would be a set of variable customers in which the contribution from financial stability score is low. So these are the customers where there is an issue, maybe in terms of financial stability from the customer. So they might not be paying you the premiums as expected. So you have to see for a different strategy altogether. Maybe you try to address the challenge that the customer is facing if the premium amount is too high up for them to pay, so that a different product can be then attached to them, saying that if you are not happy with the current product, you can maybe look at a term plan that you are that is there as an offering. Maybe you pay maybe 10,000 and then have this facility available, which is comparatively less to what the current premium that he or she is paying. So that is how we try to address those strategy issues that business team will also face. So
Sorry, but there are two. The answer is twofold. One is when the data is talking about the financial stability as what is being discussed right now. And when the business is also being sourced, and this is more on the banker side of things, because from being a bank customer, when the sales officer or our agent is trying to discuss with the branch manager, because what will happen is branch staff will also be there, which will be discussing with our sales representatives, and the footfalls which are happening within the bank also are being taken into consideration. So the business model in is also in such a way that probably these data points will never be coming onto the system because of the regulatory walls that we have between banca and the insurance company. But at the back end, people, while doing this at a need analysis basis, will always be looking at what is the monthly average balance, which is MAB of the customer, which is there in the bank. What is the average quarterly balance which the customer is also having within the bank balance? But this is more like a softer conversation which happens at the ground, which ideally does not form a part of the system. And hence, financial stability at a need analysis stage, when it is more of a discussion with the customer along with the bank branch executives, forms an important and integral part of solution process wherein we know that the customers usually are having a better financial stability thereof. And rightly mentioned, so the gaps will also be there because now when the sales pressure starts pumping in, you would want to keep on selling it, which means there will be a dilution in terms of the stability that people will also be trying to look at because as we were also discussing, if it is sales pressure, agent will be selling policies to another agent, or if there is a sales pressure, possibly whosoever wants to look at um, tax saving during the financial year end will be the one who will definitely be investing. And next year, maybe he will not be needing an insurance policy as a tax saving instrument for him. Then he might go with a FD, which is a fixed deposit, which is a tax saver FD for 5 years or so. So all of those churning aspects will definitely be there, which may or may not be captured in the system as a whole.
And at the same time, like for the IB, would you say that all of the, so you mentioned like you have like 60 variables. Would you say that all of them have the IB score between the specified range, like 0.15 to 0.5, or it depends?
No, in the final for the final model iteration, it would be close to 8 to 12 variables, which would be in that range. And what happens is maybe it would be close to 15, 16 variables which would be in that range, and then you have those correlation plots saying that we have to avoid multi-collinearity, and then we reduce down from maybe a 16 to 8 kind of a thing, and then we go with those final 8 to 10 variables at a grade.
So you go with the final 8 and 12, and you still put them, you still categorize them according to this one.
Yes, yes. So, so it is not necessary that all 7 categories are to be there in that final score. It might so happen that maybe business specific score that we are mentioning here would not be there. And also what happens is, as we are discussing on IV and WOE, when we do these steps before the iterations, we might arrive with maybe 10, 12 parameters that are there. And it might so happen that after identifying these 10, 12 parameters, and when we have gone ahead and used some algorithms and found out that the results are not that great. So what we do again is come back to this previous step, try to do IV and WOE in a different iteration altogether. Maybe earlier you try to bin into 3 or 4 categories. Now you try to do it maybe 5 to 6 categories, and again reiterate the whole step so that you arrive at those results that are expected. So this is a iterative process that we do at our end regularly, and then only those metrics are compared and then shared with the user.
And possibly when we are trying to look at random forest one maybe decision tree is something that has been as a basic technique. While random forest will have its advantages over decision tree, what will also come out for binning is a split that we usually see within that tree,
Yeah, I see.
which means if we say that a bigger chunk is actually attributed to a selection or a binning that we have done, which means, for example, the tree is split into two categories, saying that we have categorized customer uh, age into 0 to 40 and 40 to say 50. For all practical purposes, 18 to 40 and 41 to 50. Now, with the split that we see in the decision tree, if 18 to 40 is a split wherein possibly 90% of your data has come in, so you would want to split the category of 18 to 40 into more bins, and then you try to identify which is the category which is allocating to your most granular way in which the model can also talk to these variables.
I thought you also could use that like as a pre-processing step as well, right? Because like during like some of the packages, like you got the option to bin based on the percentage of the data. For example, like if the percentage of that category is less than like, let's say like 5%, then it just like automatically be grouped.
Yeah. So when we are grouping, these are certain binning techniques that are available. We can use and check which is best suiting for our case.
Small question. So like, do you have only determine like the financial stability score and like the payment score? Like, do you like consult with the other agents to determine like, oh, is this like a good score? Is this a good range of the score? Or like, do you come up with just like a median and you kind of plot them against it?
These scores are computed scores. It is not a mean score that we are having here. We are converting the probabilities that these inputs have a weight.
Like, do you determine like which one is like a good score, like a bad score?
Okay, got it. So generally what we say is, for example, since we are converting this to a credit score back in India. So back in India, what we identify is overall score, which is like 780 or more on a scale of maybe 750 or more on a scale of 800 is observed to be a good score. So once this scale is set for our use case, maybe in this case, if you are trying to maybe predict a lapse or unstable customer, then the higher the score, the bad the customer would be in terms of lapsing. So if the score of if the score of the customer is maybe greater than 700, we might say that the risk of that particular customer lapsing is high. So he is a bad customer for us. So that is how we decide.
And to add to that, score will ideally mean the value that we are typically seeing through this. Suppose IB is that indicator. You will also want to see the correlation that it is having with the final output or the independent variable. If it is positively correlated, then obviously higher score is higher for you. If it is negatively correlated, then lower score will help in improving the final independent variable or the accuracy of that model. So that is how it will be treated here.
So this we have discussed yesterday, in which we expand into the final business user. And again, I have talked about the PSI calculations. What are the thresholds that are to be there?
Sorry.
So this is what we have discussed a little while ago, in which if the population stability index is like less than 0.1, we can say that the model is pretty stable and no changes are needed in the iteration in terms of the stability consideration. And if it is somewhere between 0.1 to 0.2, we might say there is a slight concern around the model. But yeah, we can have that as a consideration and see if any improvement can be done. And if it is greater than 0.2, then we have to look back and say that we have to do some changes in our model building activity. So be it from the data collection, data pre-processing, we have to again relook what we have done and try to improve the activities that we have done. Again, capture rate is what I was explaining earlier. What we generally do is we when the model is trained, we try to have those train set uh, probabilities divided into 10 equal segments, which are called deciles. So these 10 deciles, when you map them with the actual output that is there, so how are the capture rates across these deciles? So ideally, what we expect it to be a smooth, steep curve of decreasing trend across these deciles. In the first two deciles, where we see the highest number of fluctuation or bad events that we try to target, and going down the deciles or with the probability, the percentage capture rate of the bad events is also on the lower side. So the better the model, the higher the capture rates in the first three deciles. Then this can be shared with the business users as well, the bandwidth that they also have. What we typically do is try to identify those top two and top three deciles on the resources that are there. In some cases, it can be only one risk decile that can be shared with the business team, or if the business team has the bandwidth in a particular month, it can be so that we are sharing top four risk deciles as well. So it depends on the volume that we can handle and then how to formulate our strategies on these policies that are there. Also, what we can see here is the distribution of the population across these 10 deciles is uniform. It is also a representation that our data, our model is stable. For example, if the model is not stable and we have those fixed probabilities that are there as a cutoff, and in the out of time testing, if you are trying to plot a similar graph, it might so happen that these the distribution that is there would not be uniform and it would be skewed to maybe a high risk or a low risk. There would be some skewness, and then we can identify from that graph as well, saying that if there is any data instability or population instability that is creeping in, we can identify from these graphs as well. And then obviously PSI would help us in arriving at those metrics. But yeah, this is also one visual representation which would help us to see if there is any change in data trend in the out of time testing, or in the pilot that we are doing, or in the time of monitoring that we are having. So plotting these graphs and trying to see the distributions, the capture rates, um, uh, the KS value would help us to constantly monitor what we are doing and how the model is performing in line, or has it deviated from what we are expecting. And maybe one more step that we were discussing yesterday was to identify how to do a pilot with the business teams. What we generally do in the initial phases where the model results are explained to the business teams, we try to have a small pilot in collaboration with them, saying that when the pilot is done, the results are plotted and published and submitted to the top management as well, saying that these are the observations that we have done as a team collaborating with the business team, and then these are the outputs. And then the top management also gets into the confidence, saying that yes, the results are in line with what we're expecting, and then it can be rolled out on a larger scale across the regions given. So what we try to do is split the data into certain pairs. So what we call them is test and control groups. These test and control groups are not like that. There are only two pairs, or there is only one pair of test and control. It can be a multitude of pairs that are there across regions. For example, maybe in the northern region of Vietnam, there are two specific locations which are identical in terms of their behaviors, in terms of the persistency numbers are considered. And then out of those two regions, we pick only those profiles of customers, maybe from a similar occupation or similar income levels that are there. So we try to nullify all other parameters which can impact the behavior of customer, saying that we have standardized to such extent that only the strategy that we are employing on those buckets becomes significant. Maybe just to clarify more, the effect of parameters related to the customer profiles, the demographic, the financial stability, the branch level parameters. To keep all of them uniform, we would select two identical segments or groups so that all of the parameters remain constant. Only the strategy that we are putting on those groups as an actionable is the changing parameter between these two groups. So in group one, what we do is we will continue with business as usual. The process that business is currently doing, we would imply or continue with the same strategy. On the second group, which we are calling as the test group, we will change some strategy. Either we would do a pertinent calling, increased calling to those customers, or do some changes in terms of maybe sending one more message to those high-risk customers saying that this is a reminder that we are sharing to you on maybe T minus fifth day. Just 5 days before the due date, we are just reminding them that on so and so date your premium is due. Please renew your policy. So such campaigns would be then executed on that limited pay. So these pairs, as I'm saying, maybe in the southern region we have identified two pairs. In the northern region we are identifying two more pairs. In the central region we are identifying 3 to 4 pairs. And out of all these 10 pairs, we would then compare maybe after 60 days or 30 days window that is there for the renewals to happen. We would compare back those results, saying that strategy one, sending out an SMS to the customers prior to 5 days versus business as usual. What are the persistency numbers improvement that we are observing? Maybe in group one it is 78%, and in group two it can be 79%. It might so happen that the persistency numbers have not improved and it is still the same. It might so happen that the persistency figure have decreased. So we have to analyze what is the reason. We have to try to understand the pulse from the field level, saying that exactly whether these are the activities that we have actually done or not.
So, what also becomes important is the kind of campaign that is being thought of for creating a difference between these two standard areas or standard cohorts that we have identified. If within a given region we have identified two cities which seem to be equivalent and standard across, city one is where there has to be a different category of campaign to be applied. It means that if at all calling is increased, if at all SMS is increased, if at all a visit has to be done, if at all you want to add some more thoughts from the business to how to tackle these renewal people, that becomes your start point and as a first point of contact there. Now with these campaigns, you will also want to see the campaign efficacy or the lift that you get out of this. There might be a chance that the lift may not happen in the first campaign, which means the second campaign also will have to be done there, saying that a different strategy has to be applied to check whether this is happening or not. Or vice versa too is also possible if A and B are the cities that we have identified. If campaign is not working on A, maybe campaign should be done on B and A should be your control group and test becomes your B group. And then business team will have to do that strategy. Now, where we found that in the initial stage we did not get a good result was because the campaign that was created could not actually trickle down to the lowest level of hierarchy and it was not implemented in the fashion in which it had to be implemented. So there there has to be an evidence or there has to be a factual data that you should have for the campaign that has happened on this control group and see and match that data rather than only depending on a word of mouth that says yes, something was done there, but it did not find any results. So we would need factual evidences to have these things. Now, how do you have those factual evidences? Possibly ask a smaller application to get created or a smaller example form that gets created and the data entry happens in that form in terms of people who have been allocated some task and they have completed the task in that campaign. And this data then goes to your model and the comparison in terms of lift of that campaign on the accuracy, which means if we plot it in terms of the percentage of renewals, has has there been an increasing trend in persistency for this specific area is what may be then identified out of it.
And maybe the challenge in terms of implementing these pilots can also come up from the business angle, wherein they're saying, for example, we have divided two groups, group one, group two, and on group one we have decided that minimal calling would take place, and a small nudge in terms of a text message or WhatsApp push message would be shared with the customer. But actually, in reality, what happens is maybe in that particular month, the bandwidth of the resources is on the higher side, and the volumes that are to be handled is within the limit that they can handle too. So what they do is maybe after completing the call on group one, they will hover back to group two and do a calling on which you are supposed to not do anything. So they will do that because they will obviously think from the angle of business, why to lose on certain policies, they have to renew. So they will try to do that. So we have to document those things. When is the calling happening? When are the what are the dispositions that are being uh, captured? So then we have to identify them and see if the pilot that we are planning has been executed to the extent so that these results can be published again and then model efficacy or the impact of the strategy that has been placed is measured to that extent. So generally, 3-4 pilots we do before we go for a large scale deployment. All the results would then be published to the business teams, to the top management, and then once the approvals are there in place, then we roll out the larger deployment that is there.
So how many samples you do this one? 100, only 100, two samples.
So this we have done for close to 6 months.
6 months.
Which is like 10 pairs in each of those 6 months. Total, I think, roughly 60 branches were selected. 60 branches were selected, and then we tried to have those pilots done in those specific branches.
And what was the results for I think you mentioned like three categories, right? The 13-month, the 25th to the 68th, and the rest,
Better
right?
than-
31st, and then the rest, right? So what was the persistency uplift of each group?
So what we could see is a 3% delta that we have observed in certain regions.
Mhm.
3%. And in certain regions it would be close to 8%. And in certain regions, what we have also observed is there is a decline in the persistency
Oh, no.
that also was observed in those initial pilots. So these results are there, and we have to analyze why a particular region is not responding to the strategy that is in place. So maybe the discussions that we are having earlier, we need to have that larger picture. So when we discuss with persistency team, we keep our mindset maybe fixed or limited to the persistency numbers, maybe the business figures that are considered only from persistency point of view. So when we analyze why a specific strategy is not being responded in that particular region, then we go back and see the customer interaction touch points. So people obviously in that region are not communicating through those channels to reach out to our branches. So that is one learning that we had when we are in those initial stages of deployment. So we try to
And
include.
typically 6 months is the time wherein the model accuracy will also go on increasing every month. So the first iteration of the model will not give you like 87 or 90% accuracy. It would be hovering somewhere around 80%. Then there will be continuous discussions with the business team. New variables get added. Then again a test and control happens. And hence the model accuracy will also go on increasing. With the tuning that happens within that model, the time frame of maybe a quarter or so is a good enough time frame to establish the model in terms of making it more robust. Discussing with the business team quickly to have those things aligned. Now, because since we already have an example set in terms of how do we push the business, this time obviously gets reduced now with the details that we have. After which, because this was the very first model which was created almost like 5 years ago that we started our journey when we had joined SUV Life. And that was the time when it was a transformation journey that was also happening across different systems. And hence the time which also takes for people also to mature to adopt a statistical model. Now, once we had passed that phase, now the models that we create and deploy are at a speed wherein it is like less than a week or 15 days max, wherein the model also gets created, data also gets created, model implementation also is done within a span of like 15 days because the technology has also improved, techniques have also improved, and confidence of business users with the team has also improved. So what the team is delivering now is towards a higher accuracy.
During those pilots where we are observing certain regions not responding to the strategies that is in place, so then we dig deep and try to understand what are the challenges, maybe in terms of understanding why is that specific region not responding. So one is obviously the customer communication touch points that these strategies have to be placed through. The other point is how the field level sales team is actually implementing the strategy that was given to them. So, for example, if we are saying a ultra high risk segment customer has to be provided with a personal visit, then a specified business conservation officer would then schedule an appointment with the customer, and then he will go to him and meet him personally and then explain all the things in detail. So this is a personal visit that was scheduled as a strategy. But given that the BCO officer is also constrained with some targets at their level, so it might so happen that he will not go and meet the customer. He will just try to reach out to the customer over a call. So he is actually not visiting the customer, trying to explain the strategy that we have rolled out for that particular highways is not implemented to that extent. So we have to understand all these challenges at the ground level and then try to come up with some backups so that those strategies are implemented to at least 95%, 100% of the cases. So these are the challenges that we can understand during those initial pilots that we execute.
I think deployment options we can also take up as we go ahead. We have put up a slide of deployment strategy. It means how do you actually use it as your final deployment once the model is ready. Possibly there is one way in which you can have a Python scheduler be created as the basic way of running a specific data uh, at a defined frequency. Second is obviously there are options within Microsoft Power BI also to run Python packages. And possibly if there is a typical file that is also created, then it can also be used to Power BI as your final output. And then there is a way in which, obviously, when cloud environments are there, or typically there are certain, as we are talking about Azure ML Studio or AWS SageMaker, then you can have those Python codes as a final output being deployed there and APIs being created on top of these outputs so that consumption layer at an application level also can be looked at. But these points, let us keep park it as of now for future discussion. Or if there are any questions.
So that is the for the user, right? For the user, the final user. But that is for the showing result. It's like
Deployment.
deployment.
Yeah.
Deployment, showing the final
Deployment.
result.
Deployment.
Like how do you use it? Because now, once you have gone through the campaign, efficacy being tested, everything is certified, you would want to deploy this into production somewhere. Because now, in the present scenario, these models will be created in um, respective laptops, example. And as you want to use this into your application, laptop may not be the right fit in terms of running it because the code has to be running 24/7 if the application is also asking for a data. For example, application at an application level, you have decided to include persistency risk or persistency score into your chatbot or into your CRM application, wherein when the person is actually the call center executive is actually handling the call, he knows that the persistency of this customer is low, for which you would need an API call to be made in the backend. Once the policy details are being fetched in CRM, you would also fetch the information from this model. Or there are other ways to also do it. Either the model is run and we know that the persistency output we would be using for a given month, right? Which means we run the model monthly.
It doesn't mean regenerating and regenerating.
No, not retraining. The new data that comes in. For example, we say that we have upcoming in this upcoming month due customer
Yeah.
is suppose 100 customers. So we run the model at suppose we want to identify December month's data. We run the model in November month end and give out the data for December to pitch or to act upon to the business team. This data will be 1 month old data, and it can be also stored in a database, wherein the application who wants to access this data will either fetch the details from a database about the scoring or about the policy details or about any other attribute that we have mentioned here in that model that gets stored in a database in a table format. And whenever that application is calling it, either through certain stored procedures or through certain APIs, this can get access over that application. So this slide talks about more on the IT side of things, how to implement or push this model into production.
That means that they get the result, right? The user getting the result.
User getting the result.
And with the training or review again, right?
Depends. Depends.
But that is not the heavy part, right? That is 6 months or something we
Yeah.
review and review again, right? That is just for the communication purpose. It's this part.
Maybe probably I think Amazon has developed that model, and then when business team is asking, Amazon would run whenever
code, yeah, the code, yeah.
he will execute that code and give the output. That is one way of sharing the results, wherein which there is a certain frequency identified. Maybe the business would need it on every first of month, on maybe in a quarter, they would need that data in one time.
Okay.
So that would suffice that. But if the business wants that to be consumed at an application level, saying that I need to now call the customer and I would know, I would want to know
Risk, yeah.
if there is a risk involved, then it has to be running 24/7, sharing those outputs with them continuously. So then there has to be
This
some.
is a discussion that has to be also done with the IT team. wherein what is the requirement of application. One is IT team obviously will be supporting in terms of giving that infrastructure of having this model deployed either in Power BI or as onto a server, because laptops may not be the end objective that is being looked at for running such production workloads, which means you would want to put it onto a server where Python is installed, has some connectivity with internet for downloading certain files. Once that is done, possibly this should also be a scheduled way of doing it. There are ways in which it can be also scheduled. The task run is scheduled. If it runs daily, if you want to run it daily, it can be run with a daily frequency, which means a pipeline also has to get created of infusing new data on a daily basis, and the model also churning out the result and giving it to the end user. All of these aspects have to be also dealt with carefully, because we do not know, since we understand the data is small, the Python package will also not consume those many resources in the backend to run that model and give an output. Hence, it is fine. Otherwise, then we also have to go and understand what kind of server requirements are there, what kind of RAM would be there, what are the cores that are required for that server, what kind of processing power does it need. Do you want to also look at an OPEX cost for doing this or a CAPEX cost of investing into an on-prem server? There will be ways in which the same thing can be pushed onto cloud, so that the operational expenditure is then incurred on top of it and not a one-time investment of a bigger server. We can possibly use AWS Lambda functions to host Python codes and run it in a serverless kind of a situation. So there are a lot of options which can be looked at, but these are all deployment options typically. These
In SUD, do you have a dedicated IT application support team for this deployment? That means, is it like, or is it that the IT team will just provision the resources, any pipeline, scheduler job, and the application itself will be handled by?
So we do all of that at our end.
So the IT team will just provision.
IT team would be provisioning that for us in terms of an infrastructure. We give the requirements of that infrastructure. The infrastructure team would provision an on-prem server for us if we want to run it on-prem. There are certain APIs, as we have discussed earlier, which are more like a document creation kind of APIs, which use AI/ML techniques to convert those Word to PDFs or any other PDF being used and creating a similar PDF out of it, and API integrations with our on-prem to get data warehouse details into that, and on the fly create the PDF and also share onto our WhatsApp platform. So such kind of complex decision-making platforms have been created along with WhatsApp as an interface, AWS as AWS Lambda functions as a base for transactional processing, creating on-the-fly PDFs with an ML code running in the backend, getting data from data warehouse through APIs that run on the data warehouse, and all of this would happen within a span of 2 or 3 seconds.
So your team will handle the.
Yeah, we all handle that.
Management.
Yeah. Architecting it, creating it, and handling it all is done by the team.
I think with this, we would close this session in which we were trying to emphasize on the parameters that we could not discuss on day one. I think during those earlier discussions with your team, what we observed is, I think most of the model building activities have been covered by DLBM team, and I think big round of applause for you guys as well in order to create this model. to that extent, where which it is performing as well in those 6 months of out of 10 testing that you have also performed. I think trend analysis, feature and correlation analysis, algorithms. I think you have used multiple techniques that were there. Variable importance you have plotted, performance metrics also was done to some extent in terms of confusion metrics, precision, accuracies, F1 scores have also been given. So the deck that we are showing is from your
Yeah.
information that we have plotted out. We just wanted to showcase that all these features have been covered, and I think some minor or what we say maybe some extra parameters that can be looked at so as to have the complete picture saying that yes, the model is 100% ready maybe for the deployment in terms of considering the business readiness as well for the volumes to handle. So maybe that connect or maybe those minor tick marks can also be done in the next course of sessions that we have. We will try to maybe analyze those figures and also try to see if they're also on the same page or not. I think data definitions were in place. I think T plus 60 is what the data definition that you have considered. What we in India do in this definition is to have business input also be considered. So, for example, in India, it is a 30-day window that we provide as a tax for the customer to pay those premiums for the respective policies. So when we are initially discussing internally within our teams, we also thought on the same lines, considering that T plus 30 would be my definition. But when we discussed with the business teams, what they were saying is maybe I would not look at T plus 30 as the definition. I would still want to have some backup. For example, if on T plus, I cannot wait for a customer to pay the premium till the last day of the grace period, the 30th day. Why don't we have it maybe at T plus 7 or T plus 14, and then try to predict if they're paying within those 7 days or first 14 days. And then if they're not paying, then our action or our calling teams would then try to have some strategy on top of that, saying that yes, the customers who are predicted on the lower risk, saying that they will renew their premiums within T plus 7, they will observe, yes, the renewals are coming, 70% of the renewals have come. Now the rest of the 30% where the premiums are not being made, they will then start calling or do some strategy on top of that after the 15th day of the due date. So this is how they wanted us to create. And then we also were in line with them saying that yes, I think some backup for the type 2 error of the model is also has to be accounted. So we have changed our data definition to T plus 15 kind of a thing from T plus 30 so as to give that buffer of 15 days to the customer. So this is maybe a definition change. Maybe you would also wish to look at in discussions with your business teams is what we suggest.
And this gives you also an availability of playing around with those dates, because now when it is a actionable insight that has to also happen for the business, you would typically want to say that look, I have like a 60-day window with me, but do we want to wait for the last day to actually spring into action? We might want to look at dividing into three sets of 10 day each and try and see if the accuracy, what is the accuracy of the model for 10 after the due date, how is it performing for 10th day, how is it performing for 20th day, and then between 10th to 20th, business team can go and interact more with the customer. Between 20th to 30th, they can improve or maybe explain more details about policies being lapsed and how the customer may not be enjoying the benefits of the policies further. So variation in terms of the discussions that have to be done is where you would also be giving them time, the business team, and you also know that your model accuracy will also improve over time. Because if you go and commit with the business saying that model accuracy is to the tune of 80% at T plus the due date plus 10, my model accuracy with T, which is due date plus 20, is to the tune of 85%. So which means I can predict during this time window of 10 days, 5% or 6% more than what I could predict earlier. And from 20 to 30, the model accuracy will also go to a level of 87%. With this thought into place, when you try to categorize it into these three categories, you can very neatly and cleanly discuss with the business user saying due date plus 10, due date plus 20, due date plus 30 is where you want to focus it because my accuracies are improving over time. And the chunk that you will always be telling to the business users because you will keep on showing that the accuracy is always perfect for you and always hovering between 85, 90, whatever accuracy that comes out of the model. That kind of confidence always gets built with the business user with having this kind of a bracket of time period with you.
Mm. And maybe the second point is the distribution of the events. What we could observe from the initial data set is there is a 70-30 distribution of labs to infos to labs ratio. And I think it is good to go without any sampling technique that can be applied. I think it is a straight to start with kind of a data set without any imbalances that are there. And but what we have observed is, I think going down the line from 70-30, in the time where the 6 months testing has been done, in that time period, the 70-30 has converted to 65-35 is what we have observed. Maybe there could be some changes in the trends of the data, which we can look at in detail, maybe in the coming session. Even then, 60-40 is also a good set to go ahead without any sampling technique to be applied. I think this step is also a tick mark, a check mark that we have achieved. No discrepancies in that as well. But going forward, if there is any decline or variation in the distribution that we are observing, then I think we should look at some sampling techniques also. Or maybe in another use case that you are trying to build, maybe you can look at some of the techniques like smoke, undersampling, oversampling. All these techniques can also be looked at so that to achieve that balance between the good and bad events. Again, I think transformations in terms of normalizing, transformation in terms of maybe categorizing those variables to a certain extent has been done. We can look again in detail, saying what can be done maybe there in terms of those specific variables that we were discussing. Occupation, if that can be discussed with the business team that is there, can they help us in categorizing those 2000, 3000 cardinality points that are there and maybe into 5, 6 groups with their help? If we can do some maybe iterations also, I think that is a step we can include here. And also maybe when we are discussing with the business teams, we would like to have more data points which can be used or try to see if there is any correlation or significance coming out from those variables. I think that can also be done here. I think algorithms wise, a plethora of options have been explored. Logistic, random forest, gradient boosting techniques have been used. So I think from algorithm point of view, I think all the points were ticked. Again, I think for gradient boosting, you have applied some parameter tuning as well. I think that also was mentioned in the deck. So I think that we can again skip. Performance metrics is what we are trying to emphasize on. Is more on the KSI and PSI values just to check if they are also in the range to make sure that the model is stable enough. I think those we can have those computations also included in your analysis. Then I think business teams would appreciate it to greater confidence. And then, as I was saying, stability indicators, which is the PSI and CSI, which can be looked at as well. So these are the observations that we had from the initial discussion that I think we were having 3 months earlier when all those model points were explained to us. Uh, Maybe in today we can go through the data points, the steps. Yesterday we were going through them roughly, but today we can have a deep dive into the data points as well.
I think we can jump into the coding.
Okay, yeah, we can do it. It's up to you guys. Would you guys still have anything to share, like the overview? If you don't have anything left to share,
No.
you just go to the.
Yeah.
Okay. It's fine.
So maybe we'll take 10 minute break.
Yeah, we'll take a 5 minutes break. We jump into the coding session.